Alright folks, this is some problems from your 4.2 homework. 4.2, we're learning the differences between classical approach to probability and the empirical approach. So I'm just going to give you a couple of examples of each. So to the right, there's the outcomes possible when a couple has 3 children. So this is like before they've had their kids. These are all the different things that could happen if they do happen to have 3 kids. So all boys, all the way down to all girls, with every combination in between. Alright, so it wants us to use this list. There's 8 total outcomes here. So of these 8 total outcomes, the idea is how many of them are among 3 children, exactly 2 are girls. So there's one with 2 girls. So there's 1, 2, 3. So the answer to part A would be a probability of 3/8. Okay, and then part B says exactly 2 boys. Alright, well that would be 1, 2, and then down here we have 3. So again we get 3/8, and if you think about it, that should be equally likely. This is a very symmetric distribution. And then part C says among 3 children, exactly 3 are girls. Well, there's only one way, the very bottom down there, that all 3 are girls, so that's 1 out of 8. Alright, that was an example of the classical approach to probability. Now we have the empirical approach. The empirical approach says if you have an experiment that you repeated over and over, take the number of times an event occurred, divide by the total number of trials, and you've got something that approximates that probability. So in this case, we got a gender selection technique that some company is offering, and it's offered 254 baby girls and 23 boys. So based on that result, like a whole lot more girls than boys, does it appear the technique is effective? And I mean, obviously just by the numbers it is, but we want to compute a probability because that's what's going to determine this. Right, you would assume a 50-50 chance, boy or girl, because there's 2 outcomes and we're looking at one outcome versus the other. But if we look at the probability the baby will be a girl, we're looking at how many times there was a girl, 254, and we're dividing that by the total number of times the outcome was repeated, or the trial was repeated. So take 254, add 23, you get 277. And now take 254 and divide by 277. Alright, and you get 0.917 roughly. Significantly higher than a 50-50 trial. Okay, so we would conclude, yes, it does appear that the technique is effective in increasing this likelihood. Alright, a test for marijuana use was tried on 209 subjects who did not use marijuana, so they didn't use it. The test result was wrong 207 times. Based on the available results, find the probability of a wrong test result for a person who does not use marijuana. Alright, so it was wrong 7 times out of the 209 subjects. So 7 out of 209. Alright, again, I'm going to round this to 3 places. So this is what empirical probability does. It takes 0.033. It takes data that's already been collected or data that you could collect, and it approximates a probability based on that data. Alright, and then B is an unusual for a test to be wrong. So they want us to use 0.05 as our cutoff for unusual. And yes, this is unusual because 0.33, our actual probability, is more rare than that cutoff. Okay, so now we've picked up another thing that's considered unusual, and that's the 0.05 probability. So we've talked about 2 standard deviations. Anything that falls outside of 2 standard deviations is going to be considered unusual. Now we're going to pick up a probability of 0.05 or less. is going to be considered unusual. Alright, and then last question, again, this is a theoretical probability off a theoretical game, and then we're going to convert it to odds. So a modified roulette wheel has 44 slots. One got a 0 and a double 0. The others are numbered 1 through 42. You're placing a bet the outcome is an odd number, okay? And in roulette, we don't consider 0 or double 0 odd or even, okay? So 1 through 42, we're looking for the probability of winning. So that would be the number of odds divided by 1 through 42 plus the extra 2 is the 44. So divided by 44. Alright, and then these numbers 1 through 42, if you think about it, because we end on an even number, there's going to be exactly the same number of evens as odds. So half of these 42 numbers are even, half of these 42 numbers are odd. So there's 21, half of 42, 21 odds out of the 44 is our probability of winning. Okay, now what are the actual odds against winning? Alright, the odds against winning is equal to the number of ways. In this case, you could do probabilities as well, but it's the number of ways you don't win Alright, so the number of ways to not win divided by the total number of ways to win. Alright, well, we know the number of ways to win is there's 21. That's the numerator. So that's the denominator of this odds against. Right, odds against has that number on the bottom. And the number of ways to not win. To not win this are the other 23 ways. Alright, so 23 to 21. Okay, that's the actual odds against winning this game. Alright, the third part of this says when you make a bet on this game that you get an odd, your payoff odds are 1 to 1. So if you make a $20 bet and you win, they want to know how much profit do you make. Well, profit odds, if it's 1 to 1, that's net profit to the amount of your bet. So for every dollar you spend on your bet, that's how much you profit back. So the answer to this one's just plain old $20. Whatever you bet's what you get back. But what they're asking you here is how much profit should you make in theory on a $20 bet if you could convince them to pay you the actual odds against instead of payoff odds. Right? They're paying you payoff odds because of even odd there's a 1 to 1 chance, but they're not counting those 2 zeros and double 0 slots. So in reality, if you go back to this last one, 23 21st is the actual odds against. If we multiply this $20 times 23 over 21, $20 times 23 divided by 21, I should be getting about $21.90 for that $20 bet. Alright, but because they're not counting the 0 and the double 0 in there, they're giving me $20 back instead of 21, and they're going to keep that $1.90 as like house money. Alright, so those are some examples of theoretical, or what we call classical approach to probability, empirical approach where you're using data to come up or approximate the probability, and then this last example is kind of giving you an idea, converting it to odds. All different topics that are in that 4.2 section in your homework.